So this one, organic. Organic chemistry is all about carbon compounds. And the very first basic thing that you need to do is it's all carbon compounds. So living organisms are pretty much carbon compounds. Fossil fuels made out of living organisms, that is also carbon compounds. The first thing is you need to learn how to draw the correct structures. So there are all types of formulas. The first one is, I mean, you have molecular and empirical formulas. A molecular, remember, they're going to be very specific about the formula that they want you to write. So you have to be kind of really understand the differences between all types of formulas. And the first one is, I mean, molecular formula, empirical formula, hopefully everyone knows that. Like I'll just do one example, won't go into a lot of detail with this. So they might ask you to write the molecular formula, they might ask you to write the empirical formula. For example, if glucose has this formula, its empirical formula would be C1. It's the simplest ratio, C1H2 and O1. That's the empirical formula. So molecular formula tells you the total number of atoms, but it doesn't tell you how those atoms are connected to each other. The second one is the way the atoms are connected together. That's your structural formula. Now, a structural formula gives you information about the arrangement of the atoms. So it provides information about the arrangement of atoms. What it doesn't do is, it doesn't know information about the three-dimensional. It's not a three-dimensional representation. So it's not a three-dimensional representation of the molecule. So it doesn't tell you the shape. Okay, so remember, a structural formula is not the three-dimensional shape. It just tells you which atom is connected to which other atom. For example, if I have carbon, so if I have carbon with hydrogens, so it doesn't matter in what direction are the bonds. Like you can write all the hydrogens in one direction, like maybe one over here, then there might be one on this side, right? Both of these represent exactly the same formula. I mean, this thing and this thing are exactly the same. It doesn't matter because this is not the actual shape. None of these are the actual shape of the molecule. They're not the shape of the molecule. So they just tell you which atom is connected to which other atom. That's it. So these two are exactly, I mean, they're exactly the same. So don't get confused whether the H atom is pointing upwards or it's pointing on the left or pointing on the right. As long as it's connected to the same carbon atom, it's the same exact thing. TK, is that part clear?
Yes, sir. Yeah.
Yes.
So it's going to be the same. Like the three-dimensional shape of the molecule would be, we did shapes. What happens when you have 4 bonds? What is the shape of the molecule?
Tetrahedral.
So it's tetrahedral, and so one bond over here, one bond over here, one on this side and one on this side. So this is the actual shape with the actual angles. This is 109.5 degrees. So don't confuse it with the actual shape of the molecule. It's not. Now, the first thing is structural formulas, and we're going to talk about the first type of structural formula, which is, so number A, remember they're all different types of structural formula. Number 1 is a fully displayed formula. So now a fully displayed formula is, so they're going to be very specific. They're going to ask you to draw a fully displayed formula. So a fully displayed formula, when you hear the word fully displayed, it means that you show every atom and every bond. Every single one of,
sir?
yeah.
Could you go up for a second? I think I just want to see something.
This one. And what you can do is you can have I'll post the link of the board as well. I mean, you can't open it on your mobile, but on your desktop or laptop. Just a second.
Yeah, that would be amazing.
I mean, you can see the screen, but you can have the board open in some other window so that if I move somewhere, you can still go up. I said now coming back to fully displayed formulas, right? Every atom, every bond has to be shown. The first thing is we should learn how to draw the correct structures. Before moving on, we should learn how to draw a correct structure. So first thing is, who makes how many bonds? You've got group 4, group 5, group 6, and group 7 elements. Now, group 4 makes 4 bonds. I mean, they make 4 bonds, usually. 5 makes 3 bonds. Normally, they can also make 5 bonds, but normally it's 3. 6 makes 2 bonds. And 7 makes... So 7 makes 1 bond. In group 4, you've got carbon and silicon. We're mostly interested in carbon. In group 5, you've got nitrogen and phosphorus. They're going to make 3 bonds. Mostly it's nitrogen that we'll deal with. Over here, you have oxygen and sulfur. In group 7, you have fluorine, chlorine, bromine, and iodine. So you've got all these elements. So the first thing is you should know who makes how many bonds. So as an example, if I draw a random molecule, and I'm drawing I mean, it's not exactly a correct version, but so I'm drawing this molecule, and we can have C double bond O over here. So focus on this molecule first. Now, this is an incorrect molecule. Did I draw the first carbon correctly? How many bonds should carbon make?
4.
It should make 4 bonds, but over here it's making 1, 2, 3, and 2 on this side. So that's making 5 bonds. That means I drew it incorrectly, which means I need to get rid of, I should probably get rid of 1 hydrogen. I mean, right now I'm just doing some random, just trying to draw a correct structure. You can do anything that you like. So we're just trying to figure out or learn how to draw the correct structure. Over here, I haven't mentioned hydrogen. Remember, hydrogen has 1 electron, so it only makes 1 bond. That's about it. It doesn't belong to any group. So that's the first one. Is the second one correct? The second carbon atom?
Yes.
So
Yes.
it's making 4 bonds. The fluorine is also correct because it's supposed to make 1 bond. It's doing that. What about this carbon atom?
No.
No.
Okay, so that's not correct. So that's not correct. So I mean, we need to get rid of that H. So there were 2 H drawn extra. Now this particular carbon atom is fine. What about the next one?
No.
Incorrect.
So that means there should be 1 more bond. So I'm just going to randomly add an H. I mean, now it's correct, right? What about this N over here?
Incorrect.
So how many more bonds should be there within?
1 more.
Okay, so there's going to be 1 more, right? So there should be 1 more, and this carbon is correct, not correct? I mean,
Not correct.
So that's not correct. It should have 4 bonds, so we can have an H, right? I'm just randomly adding H. This carbon, is it fine? This one.
Yes.
Yes.
And this one has 3 bonds, right? So that's
Not fine.
so that's going to be 4th, right? I said now that's the first very basic thing, because if you can't get this right, obviously you can't do anything in organic chemistry. So whenever you draw the structure, it has to be the correct version of it has to be the correct structure. The direction doesn't matter. I just told you Like if this F over here, if it's pointing downwards, I mean, you can make it point upwards. It's still the same molecule. It's still attached to the same. It's still attached. I mean, this one is still attached to the same carbon atom. So it doesn't really matter in which direction do the bonds point. I mean, that's not relevant. The connections are important, that the molecule should be connected. The direction is not important in the structural formula or any of the structural formulas. Displayed formula is one version of that. So, I mean, this serial bond O could be pointing downwards. As long as it's connected to the same carbon atom, it's still the same thing. Now, this is a fully displayed formula. I've drawn every single bond. I've drawn every single atom in it. So that's the first formula. We can do a couple of more, like we can have even the OH, like in O levels, you have to show the bond. In a fully displayed formula, you would have to show every bond. So I said, quickly tell me, let's say I have a bucket full of hydrogens and I'm going to add hydrogen. So what about how many hydrogens should I add to this carbon atom?
2.
Okay, so there's going to be 2. The next one, how many hydrogens should I add to this one?
1.
1.
Okay, that's 1. Should I add any hydrogens with this carbon atom
No.
No.
or this oxygen atom over here?
No.
No.
So what about the carbon at the bottom? That's going to be
3.
3.
okay, that's
3.
so that's 3, and this carbon will have 2,
2.
2.
and I think the rest is fine, right? So that's the first basic concept, drawing the correct. I mean, learning how to draw the correct structure. Now the next one, let's move quickly. ठीक है उमर, I'll send it. ठीक है. So next one is the next type of formula is, now first thing, when they say draw fully displayed, draw this. Every atom needs to be shown. The next formula, the next type of formula is that's a condensed version of it. So it's the condensed structural formula. Now drawing this one is slightly difficult. Condensed structural formula, it's sometimes what will happen is, I mean, the only advantage of a condensed structural formula is that number one is that it saves you space. And it's going to make it difficult for you to count bonds. Like in the fully displayed formula, you can see all the bonds, but you can't see anything happening, or difficult to count bonds, who is forming how many bonds. So it's difficult to spot any mistakes you've made. So anyways, it saves you space. For example, sometimes what will happen in your exam is that they'll just give you one line. Now you can't draw this entire thing on one line. Similarly, you can't draw if you're just given one tiny line, you can't draw this entire thing on that one line. So fully displayed, they consume a lot of space. Condensed, they don't. So if I try and draw a condensed version of any one of them, all you have to do is this thing. Like if I have this molecule and I'm going to draw the condensed version, what you can do is you can go in any direction, whichever you like, top to bottom, right to left, whichever direction. Usually the preferred one is that if the molecule is drawn, just travel left to right. You just start traveling from the left, and start moving to the right. That's the convention, but you can go in any direction, whatever you like. And you start writing all the carbon atoms. So left to right, that's 1, 2, 3, 4. So there are 4 carbon atoms left to right. So I'm going to talk about the first carbon atom at the start. If you focus over here on the first carbon atom, it's attached to 2 hydrogens. So what you're going to do is you're going to write carbon with 2 hydrogens. So it's going to be CH2. That's the first carbon atom over here. Is that clear?
Yes.
Yes.
Then you've got a double bond in between. You don't show bonds in condensed formulas. That's the first thing. Condensed formulas are basically you show the atoms, you just don't show any bonds. I mean, that's the main difference. So carbon and H, you just got rid of all the bonds. It's carbon with 2 H's. Anyways, the next thing is you've got a double bond. So that means you can include the double bond. Mostly it is included, but you can also leave the double bond because you don't show bonds. So you can even skip the double bond, but it's better to actually show the double bond because that way you can exactly know where the double bond is. Anyways, the next carbon is carbon with 1H, right? So that's the second one. What about the third one? The third one is carbon. So let's move to the third one. Now, if you focus on the third one over here, then the third one has carbon and it's got an OH on one side and it's got this CH3 group on the other side. So these are known as branches. Like you're traveling from left to right, and there are all these things that are coming out of the chain, of the carbon chain. So there's an OH and there's a CH3. So what you're going to do is, I mean, that was the first carbon atom, this one, then the second carbon atom. I'm on the third one. So the third one has an OH and it also has a CH3 branch. So you're going to write branches in brackets. Anything that's coming out of it or going below it, that would be written in branches. So carbon is with OH and it's with CH3. Is that clear?
Yes.
Yes.
Yeah.
So then there's next carbon atom. That's carbon with 2 H's. So it's CH2. And after that, it's OH. So the end is OH. I mean, you can put the OH in branch as well, but doesn't really matter in this case. So that's how you write condensed formulas. Branches would be, so branches are written in brackets if you're traveling from left to right. So we can do the we can do this one. We can try and do this one. So in this case as well, what I'll do is I'm going to travel left to right. So let's say I travel, I said choose one arbitrary direction. That's about it. So starting with the first carbon atom, that's CH2. Then the next carbon atom, it's C with 1 F. So it's a double bond and then it's C with F, right? Is that clear?
Sir, I have a question.
Yes.
Sir, so we should show the double bonds, yeah? We leave the single ones.
A properly condensed formula, like a fully condensed formula, wouldn't even show the double bonds. Like I can remove the double bonds over here even, but that would be a fully condensed, like a completely condensed formula. But usually, normally, double bonds are shown.
Yeah,
Like,
okay.
like you can.
Sir, so what do we do in the exam? A fully condensed or the one you showed?
I'll explain. Like, they're never going to ask you to draw a condensed formula, right? What they'll do is, remember, when do you use a condensed formula? You use a condensed formula when you don't have any space. Like if they give you just one line, right? And they ask you to write the structural formula, because structural formulas are of different types, right? The first version was a fully displayed formula. The second one was a condensed version, right? So then they're never going to ask you to draw the condensed formula. They'll just give you very tiny space to draw the molecule. So it doesn't really matter whether you draw the double bond or not. It's better to actually write the double bond. So remember, the purpose is they're never going to ask you for this. Is that clear?
All right,
Yeah,
sir.
so we're just showing the double bond for our ease, yeah?
Because double bonds are important, so it's better like you should show, because it wouldn't matter. The molecule would still be on one line, right? So show the double bond, right?
Yeah, okay.
Take it. So I'll do this one, CF. The next one is C with O, so that's CO. And make sure that this is clear that they're never going to ask you for the condensed formula. They'll just give you a very tiny space where you can't draw this entire thing. So they're basically expecting you to write a condensed version. Anyway, so you have CF, CO. And after that, what about the third one over? Sorry, the fourth one. What would that be? That would be CH. And there's this NH2 branch. So it's CH with an NH2 branch, which should be put in brackets. Is that clear?
Yes.
Yes, sir.
Then you have another CH, and this time you've got a CH3 branch attached to it. So this one is CH with a CH3 branch next to it. And right at the end, how would you write this condensed version? What would this be? Like if I condense this, what would it read?
COH.
COH.
So there are two options, right? It's either COH, right? But this is usually written as CHO. And I'll explain this one minor point about why this is written as CHO and not COH. It doesn't make a difference. It's still the same thing. It's COH or CHO. Because remember, the CH group is always written first, and then the O. If this thing had an H, you would write CH. Like everywhere you go, you first write C and how many H's are next to it. Do you get my point? So
Yes.
over C with H, that's written first, and then the branch, right? So over here as well, it's CH. I mean, you count the CH, like how many C, if there is no H, don't write H. But you write the CH first, the number of C and H, and then the O comes in. So that's one convention, right? In this case, that when you're compressing it, CH2, CH, I mean, you first look for C and how many H's are attached to it. None in this case. Then you write OH branch and CH3 branch. Then over here it's CH2. Then you'll have OH. Okay, so let's do one more example about this, and also to clearly tell you this small point, this fine point, and that reason is that there is going to be a functional group which we're going to study later that's called an aldehyde. This is an aldehyde, and there's another functional group which is an alcohol. Okay, you must have heard about alcohols, but not about aldehydes. The problem is why we should not write it as COH is because this thing is OH. So this is a different functional group compared to this. So when you compress it, if you had written OH over here, COH, then it would look like in the condensed form, it would seem as if it's an alcohol. Do you get my point?
Yes.
Yes.
So just make sure in the condensed version.
So what's the R?
Sorry, the R means the rest of the molecule. Like whenever you don't
Oh,
want to,
okay.
whenever you don't want to draw the rest of the molecule, just write R. That's it. And R from now on, it's known as the rest of the molecule, and it's most of the time referred to as a carbon chain. Like there's a group of carbon that's attached to it on the left side. So, I mean, basically what that means is that R is not H. R is the rest of the molecule except H. Like it's not H. I mean, there's a molecule over here that's continuing on this side with carbon chains, right? So R, C, H is written first and then O. Over here, the same thing. R, then C, then it's got bonded to two H's. That's written first, and then the OH comes in. So it also helps us differentiate between the two. So is this all clear, this thing?
Yes, sir.
Yes.
Yes.
Yes, sir.
Okay, so
So, if you write it as COH, then would it be considered wrong or
It would most likely be considered wrong because
All right.
because then it's going to get mixed up with an alcohol. It's the convention is it's always written as CHO.
All right.
So now the next one, the third one, option C. That's a new one. That's known as the skeletal formula. Skeletal formula. So what happens in the skeletal formula is, so remember, condensed was when you're running out of space, you just condense it. And the big problem with condensed is, by looking at the formula, by just looking, if I highlight this, just look at this formula. The big problem with this entire thing is, it's pretty hard to actually tell whether it's the correct structure or not the correct structure. Do you get my point? I mean,
Yes.
like if you had missed one of the bonds or if you had missed one of the atoms, you wouldn't know. I mean, even I wouldn't know if I had missed anything over here. Like over here in the displayed version, if I miss something, then it's pretty obvious. And also another thing. Another thing is, a lot of formulas are going to be a mixture of condensed and displayed. A lot of them. If I can move this. So a lot of things, even the diagrams that they draw, it's going to be kind of a mixture of condensed and displayed. So I'm going to show you some mixtures of condensed and displayed. Like you're drawing the displayed and then all of a sudden you run out of space. So you decide, okay, I'm going to draw the condensed version from this point onwards. So mixture of condensed and displayed. So as an example, if I have this molecule, and there are carbon N, and then there are 2 more carbon atoms attached, and let's say there's a double bond, right? So at the moment, it's not a fully displayed because the OH bond is not shown. But what we'll do is, this carbon will have, how many hydrogens will be attached to this carbon atom?
One more.
One more. So instead of drawing that, I'm just going to write the condensed version like CH, right? How many hydrogens with this one?
One more.
One,
And what about the one over here? How many hydrogens?
two,
So we'll just write CH2. And the end looks fine. And this would be CH3, right? And this would also be CH3, right? Is that clear?
Yes.
yeah,
So it's
Yes,
kind
yes.
of, okay. So it's kind of an in between. It's an in between a, like some of it is displayed, like you displayed some of it, you showed these bonds, and then all of a sudden you decided not to draw the hydrogens and you condensed them. So you're going to get a lot of mixtures. And there's one other point as well, which is that if you had a longer chain, so for very long chains, you can also condense the very long chain. For example, if I have a molecule and it's got a big carbon chain, let's call that big, and it's got a carboxylic acid at one end and 2 hydrogens with this one, 2 hydrogens with this one. There would be 2 hydrogens with this one, 2 hydrogens over here, 2 hydrogens, and this one will have 3 hydrogens. So instead of drawing or writing the CH2s for so many times, what I can do is I can start with the first one, CH3. The next one is CH2, but that's repeating. How many times? It's repeating 5 times. So I'll just write 5. And then I have CO and then OH. So I've got CO and then OH. So CO and OH. So we can do that. So you can compress the carbon chain as well. Is that clear?
yes.
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 let's
Yes,
go.
sir.
So, okay, let's go with skeletal formulas now. Skeletal formulas are, they're going to ask you for skeletal formulas. Now, the purpose of skeletal formulas are that sometimes you just want to be really quick and not, so skeletal formulas are going to take space. I mean, they're like displayed formulas, but if you want to be really quick without making any structural errors, you use, just for speed, you use the skeletal formula. So for example, if I have, let me draw or copy, let me copy this one. So let's say I have this thing, this molecule, and I want to draw the skeletal formula of this molecule. So what we're going to do is, you can go in any direction. You can, I mean, just use the same left to right, for example. But you can pick just one random direction and go along with it, whether it's left to right, right to left, top to bottom, whatever. Left to right is more convenient. So I've got 4 carbon atoms that are attached in a line, right? So I've got 1, 2, 3, and 1, 2, 3, and 4 carbon atoms. The way I'm going to draw these 4 carbon atoms, and remember, I'm focusing just on the carbon atoms at the moment. So the way I'm going to draw these 4 carbon atoms is, it's this way. This represents 4 carbon atoms. The way it represents 4 carbon atoms is, the nodes over here, they are your carbon atoms. So this is the quickest and easiest way. We haven't completed the structure yet, but this is just to highlight this. Like if you have 4 carbon atoms in a line, so that's 1, 2, 3, and 4, all bonded to each other. The first 2 actually have a double bond, so I'm going to put in a double bond over there because they have a double bond, so we can add a double bond. So is this clear up till this point? That 4 carbon atoms, you don't.
Yes, sir. Sir, the double bond, should
Yes,
it
sir.
be on
Yes,
the
sir.
inside or can it be on the outside as well?
It could be anywhere. I mean, as long as it's 2 bonds, right? So the thing is, you don't show any atoms. You don't show carbon or hydrogen atoms. That's the only thing that you show, that 4 carbon atoms connected together. So that's 4 carbon atoms connected together. The line has to be a zigzag line. And between the first 2 carbon atoms, there's a double bond. And so I can write the points over here that carbon and hydrogen atoms are not shown. So carbon and hydrogen atoms are not shown. And also only carbon-carbon bonds are shown. So the carbons are represented by these dots. I mean, there are no dots actually, in fact. They're just basically, it's just exactly the line that I drew earlier. The dots are just for clarity. You can use the dots just to clarify things. I mean, the dots make things easier. So that's 1, 2, 3, 4 carbon atoms. Like without the dots, things get slightly more confusing. So it's better to actually use these dots, put those dots so that you know where the atoms are. And only functional groups are shown. So इसमें ये कि carbon and hydrogen atoms are not shown, those that belong to the carbon chain. Only functional groups are shown and their atoms. Like if there's a hydrogen atom in the functional group, hopefully everyone knows what a functional group is. We'll do functional groups later, but any functional group or atoms belonging to that functional groups are going to be shown. So anyways, I did the first 4 carbon atoms. What's attached on the 4th carbon atom? There's a double bond O and there's an OH. So the 4th carbon atom over here, there is a double bond O. So there's going to be a double bond O. And there's going to be, so that's double bond O. And there's going to be an OH as well. So there's an OH as well. So that's happening on the 4th carbon atom. Focus on the 3rd carbon atom over here. There's an N that is attached on the third carbon atom. So you're going to show the N. So on the third carbon atom, which is this one, there is an N that is attached, right? And on that N, there are two more carbon atoms attached. So those two carbon atoms would be represented by these dots. So on that N, you've got these. So on that N, you've got two more carbon atoms. So how am I going to represent those two carbon atoms? It's going to be this, and it's going to be this. Is that clear? This one. So is this clear?
Yes, sir.
Yes.
Yes.
So again, it's kind of simple. It's
Yeah.
Yes.
it's kind of simple. 4 carbon atoms. So that's 1, 2, 3, 4. That's 4 carbon atoms. Well, the first 2 carbon atoms, they've got a double bond, so that's a double bond there. Functional groups have to be shown. So carboxylic acid on the fourth one, that's double bond O and OH. Remember not to draw any straight line. Like the OH should not be pointing in this direction. It has to be like if this line is over here, the other line should be either, should be in some other direction. Third one, there's an N, so you have to draw the functional group N. And on that, there are 2 more carbon atoms, so there are 2 more dots that are attached to it. So in this way, we can write this the skeletal formula of any molecule. So what about this one? Let's do this quickly. How many carbon atoms? That's 1, 2, 3, 4, 5, 6, and 7. So we can be very quick. It's 1, 2, 3. So that's 1, 2, 3, 4, 5, 6, and I think 7. So we need to count quickly, like how many. So that's 1, 2, 3, 4, 5, 6, and 7. Is that clear?
Yes.
And I need to show the functional
Yeah.
groups.
Yes.
Okay, so on the last one, I need to show the functional groups. So that's double bond O and OH. Taken no straight line, so everything has to be at an angle. So on the last carbon atom, there's double bond O and OH. So that is my skeletal formula. And we can simply do one for this one. That's very quickly 1, 2, 3, 4. Did we do this one or not? 1, 2, 3, 4. So that's 1, 2, and 3, 4. So this is 1, 2, 3, 4, right? 1, 2, 3, and 4. What about on the first one, double bond? We did this, I think. Did we do this? Maybe not.
No, sir, we didn't.
So the first one is double bond, right? And on this one, there's an OH. On the third one, there's an OH. This is the third one. So there's an OH that is attached. So make sure they're at some angle. You have to show the OH group. So the third one, there's an OH attached. And on the third one, there's another carbon atom attached. So on the third one over here, there should be another dot. So we can draw that dot at an angle. No straight line. So that's on the third one, there's an OH and there's another carbon atom. On the fourth one, there's nothing. So that's the fourth one. On the fourth one, there's an OH attached. So we would have to show that. We would have to show that OH. So there's an OH functional group that is attached. So that's the skeletal formula of this molecule. Now it's very easy to go from skeletal formula back to this one because this carbon is making how many bonds? 2 bonds. So how many H's should be added to this one? Like if I add in
2.
2. This one is making 3 bonds, so there's going to be 1 H, right? This carbon atom is already making 4 bonds, so this one will make how many H's with this one?
3.
3.
And that one, there would be how many H's? That would be
2.
2. So remember, you can always add in the hydrogens, you can always add in the hydrogens later on. But so the skeletal formulas are like this, and you should be good with. So remember, we're done with formulas basically, and we're going to keep on revising this. I'm going to send you a worksheet as well. So we're done with formulas. Make sure you know. So first thing, they'll ask you if they ask you for a structural formula. and they give you very little space, then you would have to go with the condensed version because you don't have space. If you do have space, make sure you draw the displayed one, because it's a lot easier to get the condensed version wrong. Even if you want to draw the condensed version, make sure in the rough you draw the original molecule and then you condense it. Then it would be a lot easier to actually figure out if you have made any mistakes. If they ask you for the fully displayed, then you have to go for the fully displayed. You have to show every single bond. And if they ask you to draw the skeletal formula, make sure you know how to draw the skeletal formula. Okay? So I'm sending you a worksheet. Make sure you try and go through this one. Okay? I'll post it on the classroom as well. And it's about these formulas. Okay? So is this clear? No questions, right? All clear?
Yes,
Yes.
sir. It's all clear.
So
Yes.
Yes.
So we'll try and do naming tomorrow then. Okay. Take care.
Okay, sir. Allah Hafiz.
Love is.
All right, sir. I laugh.